Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0299 refers to a turbocharger underboost problem specifically for the Honda Civic model from 2022 onwards. This code indicates a discrepancy between the target boost pressure and the actual boost pressure within the turbocharger system, necessitating attention. The Powertrain Control Module, PCM, triggers this code when it identifies that the boost pressure is outside of a specified range. A turbocharger plays a critical role in enhancing engine power and performance by increasing the intake air pressure. When the turbocharger does not perform as expected, it can lead to reduced engine efficiency and lower power output. It is crucial to troubleshoot this code effectively to restore optimal performance in the vehicle. DTC P0299 signifies a turbocharger underboost issue, where the actual boost pressure fails to meet the target specified by the engine management system. The issue stems from various components primarily linked to the turbocharger system, including the turbocharger bypass control solenoid valve, and associated lines. The PCM, or Powertrain Control Module, is responsible for monitoring these components. When discrepancies occur, the PCM flags the issue by storing DTC P0299. The location of critical components begins with the turbocharger, mainly found on the exhaust side of the engine, and the air intake system, which integrates several hoses and valves. Notably, the turbocharger bypass control valve and turbocharger wastegate control actuator are directly involved in regulating airflow and pressure within the turbo system. Several possible causes can trigger DTC P0299. A faulty turbocharger or its components is a primary suspect, potentially signaling internal issues or mechanical failure. Additionally, leaking hoses within the turbocharger system can cause drop in pressure, leading to underboost conditions. Blockages in the intake or exhaust lines can also be culprits, as they disrupt the flow essential for optimal turbocharging operation. Finally, malfunctions in the Powertrain Control Module PCM itself can result in erroneous readings or misinterpretations of boost levels. Thorough inspection of each component involved is essential for determining the root cause. When DTC P0299 is present, several symptoms may manifest in the vehicle's performance. Drivers often experience a noticeable reduction in engine power, making acceleration sluggish and less responsive than usual. The check engine light will likely illuminate on the dashboard, indicating a need for diagnostic attention. Additionally, unusual engine noises may occur, stemming from issues within the turbocharger or its components. It's also possible to experience fluctuations in engine performance, with hesitation during acceleration or failure to maintain speed. These symptoms can lead to an overall less enjoyable driving experience, reinforcing the urgency to address the underlying issue. The first step in troubleshooting DTC P0299 is to start the vehicle's engine and stabilize the engine speed at 3,000 revolutions per minute, RPM. This should be done in a no-load condition, ensuring either the continuously variable transmission, CVT, is in park or neutral, and for manual transmissions, maintaining this engine speed is crucial until the radiator fan activates, as it serves as an indicator of normal operating conditions for the engine and the cooling system. Capture an onboard snapshot during this step, which records key data such as vehicle speed, engine coolant temperature, ECT sensor 1 readings, manifold absolute pressure, MAP sensor values, turbocharger boost pressure, and engine speed. This information is invaluable for understanding the behavior of the vehicle under these specific conditions and identifying any discrepancies in performance. In the second troubleshooting step for DTC P0299, utilize the Honda Diagnostic System, HDS, to perform a turbocharger bypass control solenoid valve test. During this test, listen for a clicking noise, which is an indication that the solenoid is functioning normally. This audible confirmation means that the solenoid is operational and engaging as expected. If the solenoid does not produce the expected clicking sound, further investigation into the turbocharger bypass control solenoid valve is warranted, as it may indicate a mechanical failure. Normal conditions imply that this part is clear of obstructions and performing as intended. Attention to the results of this test is crucial in narrowing down the potential causes of the underboost issue. The third step involves inspecting the turbocharger wastegate control actuator. Use the Honda Diagnostic System, HDS, to conduct an electric wastegate test, which assesses the actuator's functionality. It is essential to monitor whether the actuator operates correctly, activating the wastegate in response to system requirements. The absence of proper operation from this actuator could signify a mechanical or electrical issue within the turbo system. Additionally, a visual inspection of the actuator can reveal signs of wear, damage, or incorrect setup, which can hinder proper performance. Ensure to evaluate both the functional and physical state of this critical component to prevent misdiagnosis. In the fourth step, perform a thorough visual inspection of the intake air system to detect any potential leaks that may contribute to the underboost condition associated with DTC P0299. Specifically, examine the intercooler inlet pipe, the intercooler itself, and the outlet pipe, in addition to the hose connected to the throttle body. Any leaks within these components can create loss of boost pressure, severely affecting engine performance. Ensure that all connections are tight and inspect for cracks or wear on the hoses. This step is critical in ensuring the integrity of the intake air system, as even minor leaks can lead to significant performance issues down the line. The fifth troubleshooting step focuses on the turbocharger bypass control line. It is crucial to visually inspect this component for any signs of damage, such as cracked hoses, blockages, or disconnections that could disrupt the turbocharging process. Such failures can severely impact pressure levels and the overall performance of the engine. Ensure all connections are secure and the line runs without obstructions. If any issues are detected during this inspection, they must be addressed immediately to prevent further complications, especially related to boost pressure discrepancies that the PCM has logged as DTC P0299. In the sixth step, conduct a visual inspection of the evap canister purge line to ensure it is in correct working condition. Inspect for any signs of cracks, damages, or disconnections that could lead to performance issues and may also contribute to DTC P0299. An intact evap canister purge line is essential for maintaining the balance of fuel vapors and emissions. But its failure can indirectly affect boost pressure by altering the air-fuel mixture entering the turbocharger system. Ensure that all sections of the line are intact and properly mounted to their respective fittings. Any defects found during this inspection require immediate fixing, as they can compound the issues within the turbocharging system. The seventh step requires inspecting the exhaust system for any leaks or blockages that may affect turbocharger performance. A correctly functioning exhaust system is pivotal in allowing the turbocharger to operate at optimal efficiency. Focus on the catalytic converter and connections to the turbocharger itself, as any leaks here could lead to a loss of back pressure or boost pressure, compounding the underboost problem. Ensure that all components are securely mounted and show no signs of corrosion or physical damage. Addressing any discovered anomalies in the exhaust system is key, as this may directly correlate with the DTC P0299 issues indicated by the PCM. The final step in troubleshooting DTC P0299 involves an inspection of the Powertrain Control Module, PCM. If previous inspections have identified all other components as functioning normally, it suggests that the PCM may be at fault. Depending on diagnostic data gathered, verify that the PCM is communicating properly with other vehicle systems and that it is correctly interpreting input from sensors associated with boost pressure. Should no abnormalities be found in associated components, further testing may be necessary to evaluate the integrity and operational capabilities of the PCM itself. When issues are discovered with the PCM, it may need replacing or reprogramming to eliminate the DTC and restore proper boost management functionalities. After following through with the troubleshooting procedures and implementing necessary repairs for DTC P0299, it is important to conduct a final verification step. Begin by confirming that all repairs have been fully completed and that all components have been checked for proper operation. Clear any detected diagnostic trouble codes, DTCs, from the PCM memory to reset the system. A road test should then be carried out under various conditions to ensure that no reoccurrence of DTC P0299 or related symptoms appears. Carefully monitor the vehicle's performance during this test, remaining observant for any abnormalities. This step solidifies the repair process, confirming that the turbocharger system is now functioning as intended. To prevent issues related to DTC P0299 from occurring in the future, adherence to a routine preventive maintenance schedule is crucial. Regularly checking the turbocharger boost system can help identify small issues before they escalate into larger problems. Specifically, inspecting hoses and connections throughout the turbo components ensures integrity and performance. Monitoring components for leaks can significantly enhance both the longevity of the turbocharger and the overall efficiency of the engine. Maintaining a clean air filter is also paramount, as a clean air supply supports optimal turbo efficiency. Integrating these practices can extend the lifespan of the turbo system and enhance engine performance. In conclusion, addressing DTC P0299 effectively revolves around understanding turbocharger functionality and the factors affecting its performance. Symptoms such as reduced power and the check engine light should prompt immediate action to determine the underlying cause. Following the outlined troubleshooting steps methodically helps ensure that all components related to the turbocharger are assessed, promoting comprehensive diagnostics. Additionally, adopting scheduled preventive maintenance will not only help in keeping the engine operating at peak performance, but also reduce the likelihood of similar errors reoccurring. By understanding and taking action on these key points, you can maintain the integrity and performance of your Honda Civic. Please like and subscribe to the channel. See you next time.